Hello everyone. I know the afternoon sessions are a little tough, especially after the food, but yeah, I'll try to make it as interesting as possible. And thank you for joining today. It is my pleasure to present a topic that I've been working on at Fujitsu. And I'll be discussing an AutoML platform that we have developed and how it can accelerate the predictive modeling, and you can basically get from the data to insights in just minutes. I will show you the live demo, and hopefully that will be helpful to some of you. So let's begin. In today's session, I will be covering in today's session, I will be covering a quick dive into machine learning and then explain what is AutoML and also explain the inner workings and also show the live demo as I promised, and basically we'll conclude with some takeaways and we'll open the floor for question answering. So welcome to the machine learning power world, and today's world, starting from our phone and homes, we have pretty much machine learning everywhere. From the voice assistants, we give the Siri the commands, and it will create an appointment for you. And you'll be also purchasing something from Amazon. It will recommend you the products. On social media, Facebook will recommend you friends or topics or pages of your liking. To the self-driving cars, machine learning is everywhere, and it is completely changing our everyday experience in a seamless manner. But what is machine learning? So machine learning is a technique that enables computers to imitate how our brain functions, and that allows us to do tasks autonomously and also improve the performance over time through different experiences that we collect from the world. So just for an example, if let's say I show you what the red circle, green circle, red square, and a green triangle looks like, based on those four examples, your brain will try to learn some patterns from them. And even though you haven't seen green square any time in your life, you will be still able to predict that based on the four examples that you have previously seen. You'll know that what the green is and what the square is, so you can create those combinations. So our brain kind of learns those patterns from the observational data, and it can generalize to more diverse patterns. And specifically, a machine learning system consists of it starts with a large amount of data, and then second step would be to identify the rules or patterns from that data, which will collectively form an algorithm. And finally, you apply that algorithm to make predictions on new scenarios, and over time, you keep repeating this process, and your machine learning model will improve in automated way. So, for example, if we have lots of sensors that are deployed in environment that can measure precipitation or cloud levels or the wind speeds and so on, and based on that raw data, you can learn an algorithm to predict the weather for tomorrow. So machine learning types, there are three broad types machine learning algorithms are classified into. It's supervised learning, unsupervised learning, and the reinforcement learning. But our today's focus would be on supervised learning, where it assumes that you have the labeled data set to work with. Again, supervised learning, it consists of either regression or classification problems, depending on whether the predictions that are to be made, whether they are continuous in nature, or they belong to a finite set or few values. And why machine learning was considered hard until now? So traditionally, machine learning models required specialized skills, such as you have to have the knowledge of data science, programming, statistics, and so forth. And then those experts would have mastered numerous algorithms that exist in literature in order to judge that for a given data, which algorithm would be most suitable. And eventually, even after the selection part, it's not done. You have to continuously validate and iterate that algorithm through appropriate fine-tuning so that you get the best parameters for robust scenarios that you might encounter. So because of those limitations, this AutoML was proposed. So what AutoML is, so it's a technology that automates the difficult and the time-consuming part that is involved in building machine learning pipelines. And since it automates all of the stuff that traditionally humans used to perform, now it is becoming more accessible to non-expert users who do not have those specialized knowledge. So the best analogy, I think, about AutoML is that you can just think of it as a self-driving car for machine learning. So it handles all the complex part, but it can still get you to the destination safe and sound. And in this case, if we consider business scenarios, then the destination would be more like you want to achieve operational efficiency in your organization, or you want to better understand your customers' needs, or you want to support them for better user experience, or you want to maximize your profits. So AutoML could help with all of those tasks, and we will see how. Before that, let's learn what kind of tasks AutoML handles in construction of a machine learning pipeline. So in my observation, it can handle 4 key steps. So first is the data processing and feature engineering. So basically what they mean is that when you provide it the raw data, it will convert the raw data into a machine processable format and create more informative features from the existing features such that it is likely to boost the performance. The second is model selection. So as I mentioned, there exists many models, machine learning, and you have to choose the appropriate one based on your task. So AutoML can explore a vast library of algorithms which are suitable for a given problem type. And for now, our focus will be on regression classification, as I mentioned earlier. Then the third step is hyperparameter tuning. So in here, AutoMLs would incorporate the sophisticated optimization algorithm such that they can find the best combination of parameters without brute force kind of a search, or also a grid search. So with this hyperparameter tuning, the goal is to find the parameters that kind of control the learning process of the model. So it is not directly related to data, but those parameters are important in understanding how the model is learning from data. And finally, the model evaluation. So AutoML will rigorously handle all the evaluation part, and it will try different evaluation metric, and it will validate that the generated machine learning pipeline is good enough, and it generates well on the unseen data. So now I would like to list some existing AutoML platforms. So primarily, they are in two categories. I have divided them. One is the proprietary AutoML platforms, where you basically have to pay to use their service. And the other is a set of open source AutoML platforms, where you might have to do a little bit of work to get your model, but it's open source, it's free, and anyone can use it. So as you can see, all the big giants, they have this AutoML platform, and it's very popular these days, so including Google, Microsoft, Amazon, IBM, those big companies, and also some medium-sized firms like Alteryx, Databricks, H2O, and so on. And Amazon and H2O also have like their open source counterparts, which might have some limited functionality compared to the proprietary versions. However, there exist a bunch of other open source AutoMLs like scikit-learn, AutoKeras, Teapot, MLjar, and Fujitsu Sapien ML. So as I mentioned, I work for Fujitsu. So today I'll be talking more on Fujitsu's Sapien ML. And since it's open source, my company doesn't get any benefit, but I just intend to promote it more so that it can be it can be useful to some people, and it can have better visibility. And then let's talk more about Fujitsu Sapien ML. So as I mentioned, it is an open source AutoML, and it is publicly available over this GitHub link. If you just simply Google search Sapien ML, then probably it should lead you to this website. And I think the GitHub repository is quite detailed. You can also find some examples and detailed documentation as well. So what sets apart Sapien ML from other AutoMLs? So I would say there are three important distinctions that we feel that are not available in some of the AutoMLs. So first is that the way we have constructed Sapien ML is that it learns from a corpus of best and successful human-written machine learning solutions. So if you're familiar with Kaggle, so Kaggle hosts lots of data science-related competitions. They will give you a data set, and then people across the world, developers across the world, they will compete to create the best solution for those data. So we kind of leverage those competitions, and we extract the best solutions written by humans, which were winners for that competition, and use that information to train the Sapien ML score module. So that's why, and since this Kaggle competition will also have lots of data sets, so I think that gives us an advantage that our system can also robustly handle different types of data sets, for example, finance or manufacturing or social media data and so on. So those are very diverse data sets. And then our Sapien ML, it uses the three-stage program synthesis approach, which is also responsible to generate high-quality pipeline, specifically when it has not seen a particular data before, and which we think is not available in other AutoMLs. And finally, it can generate the reproducible Python code I will show in the demo for the entire machine learning pipeline end-to-end, so that it provides more interpretability on how it selected a particular model and why the hyperparameters were selected and what was the final result. So it also gives the ease to users if they want to easily integrate that piece of code with some other systems. And it also addresses the black box problem that is there in some AutoMLs. So black box problem refers to basically give the model something and it produces something, but you don't know why. So that's the problem that we try to address. Okay, time for some interesting demo. So before I jump into the demo, I would like to introduce you to this data set that I would create a machine learning model on. So I have taken a data set on hotel reservations. So that basically consists of, this is a tabular data which consists of different columns. For example, this is a number, a unique ID number for each reservation. Then it says how many days the reservation is made for, how many guests will sleep, what is the area code, and what is the purpose code, like business travel or personal, the family vacation, and those kind of purpose code. And the agency code is the number, unique number of the agency which the reservation has been booked through, for example, those vacation companies or hotel.com, this kind of agency code. And then how many number of rooms were booked, what was the charge, and what was the age of the person who booked the room. So those kind of features are available. So I call them features in the terminology of machine learning. And our goal is to predict whether the reservation will be a stay or a cancellation. So a person has booked, but sometimes we know that unfortunate things happen and we need to cancel. So given the reservation, hotel needs to predict whether a particular reservation that has been made, whether there will be a stay or cancellation. So that is captured in this status column, which is highlighted by the red box here. So C means cancellation and S means stay. So given this historical data, and this objective is also called target sometimes. So I mentioned that this is a target and rest of the columns are considered as features. Okay, so I have a snapshot of the Jupyter notebook, but I will show it live. So many of them you will be familiar with this Jupyter notebook style environment where you can connect to the runtime and use Google's GPU to kind of CPU and GPU to run your code. And right now it is CPU, so there is no GPU required to run the script. And first of all, you have to install the necessary packages. So as I mentioned, we created this SapienML library, so you have to install the necessary components so that you can use them. For now, I ran this notebook before, so it mentions that some of the requirements are already satisfied, but if your environment does not have it, then it will go ahead and install all those required packages. And the next step is to import some of the functions from those libraries, and we will also use pandas, which is a popular related library, and scikit-learn to get some functions related to evaluation scores. And third step is to load this data set that I was talking about, and I have separated it into two parts, the train data and the test data. So I have loaded those data sets, and I said that my target is a status column, as I showed in their slide. That is a status we want to predict for new reservations. So I'll go ahead and run this cell, and it will understand that here the model has to predict the status column for test data. And I already showed this data before, but I'll show it one more time, that this is our train data and status is the target. And then we also have to separate some portion of the train data so that we can do validation. So that's what this step does. And if your test data contains the ground truth, then you have to delete the status column. So that's what this step does. And finally, we call this scikit-learn main function. You say that status is your target, and you want to fit your model on the training data. So as you can see, it will create a machine learning model for you. Just notice how fast it created the machine learning model. It already did it. So if it would be human, it would take so long time. And finally, on our test data, we will do some we'll predict. So here, you can see here for the test data, for example, row number 1, the predicted status was the stay, and also the actual ground truth status was stay. So that means that prediction is correct. So it can also happen that sometimes it could be wrong. For example, if you consider row 12, then the prediction is cancel, but actual is stay. So these are the predictions on test. And finally, as I mentioned, you can use the automated scores to understand how the quality of your model is. So in this case, you get the F1 score of 0.70. That means 70% of your test predictions are correct that were learned by the model. And the final step is, as I mentioned, it can give you the reproducible Python code. So here is the Python code. So as you can see here, it can generate the confusion matrix. It can do the permutation importance. It's more technical, I understand. But if, let's say, you execute this script in another Python code, it will work flawlessly. And over here, as you can see, it considered different kind of machine learning models. So the list is over here. And then it came up with the best model. So that's about the demo. And the key takeaways from this session is that AutoML can give you several benefits if you're interested in creating machine learning models. Specifically, it can give you the speed. So as you observed in the notebook, that model development process is so fast. And then it is also accessible. So as I mentioned, by just changing the path of the data set and specifying the target variable, you could apply the same Jupyter notebook and run your own machine learning use case. So it also enables non-experts to leverage this kind of tools and the power of AI for their own use cases. And performance-wise, I would say scikit-ML or any other AutoMLs often achieve strong baseline performances. So that's a good thing. It's a good starting point. And then gradually with more data, you could possibly improve the model over time. But it gives you a good head start, I would say. And then transparency point of view, as you saw, it generates the reproducible code for each step that was taken. So it is great for integration or deployment, and it's quite easy. And finally, efficiency. So I'd say by leveraging this kind of tools, data scientists or business owners can focus on more strategic tasks and not spend time building complex machine learning models. So those are the benefits. And as like everything in this world, everything has a limitation. So I would say the current limitations of Fujitsu Sapient ML is that it only supports tabular data. For example, Amazon's AutoGluon, it can also support image and natural language kind of data. So if you have those kind of data, probably Amazon AutoGluon open source would be a better choice. And then currently we do not incorporate deep learning architectures. So even though deep learning architectures are more suitable for unstructured data, some results show that it is also effective on tabular data, but I think we still go ahead and with the major traditional machine learning algorithms in the current implementation. And third point is that, as I mentioned, it can give you the good head start, a good baseline performance, but it may not be guaranteed to achieve the best performance at all times or all data sets. But I think it's acceptable. And finally, I would say if the data set, incoming data set is too poor quality, then you might have to handle it separately, and you might have to do some additional manual processing compared to directly using this tool. So although it can handle basic kind of data cleaning mechanisms, it cannot handle very data set specific errors. So those are the limitations. And finally, anyone who is scared of whether AI will take their job, I have a closing remark that don't be like the Tom on the left, which is scared that AI will replace him, but rather learn AI and be like the Tom on the right that knows how to effectively leverage AI. And I'm open to questions or feedback. Pretty much, I think I'm on time, so very welcome.